So today's objective is to be able to identify key features in tables and graphs, review intervals, increasing, decreasing, writing it with interval notation, key features like x-intercepts, y-intercepts, and we're going to work on domain and range as well. So let's do a quick review. Using our table, can you identify the following? Any y-intercepts and explaining the meaning, and any x-intercepts and explaining the meaning, based on the scenario represented in the table. Well, the relationship in our table is talking about the number of weeks and the amount of money that you have in the bank. If we're looking for a y-intercept, that's where it crosses the y-axis, and we know the input should be 0. And so if we look at our table, we see we have an input of 0 here, and we have its corresponding output. So we have a y-intercept at 0, 300. If we're looking for an x-intercept, we know that's where it crosses the x-axis, so the output is 0. So we're looking at our output column, and we see our 0 here, and so here we have our x-intercept at 6, 0. So the question is, what is the meaning for each of these? Well, for our y-intercept, 0, 300, that means when we open the account, right, at week 0 means you just started, you have $300 in the bank. When we're looking for the meaning of the x-intercept, right, we said the x-intercept was at 6, 0, and what does that mean? Well, after 6 weeks, we have no money in our account at the bank. So that's using a table, looking for those key features for the x-intercept and y-intercept, and reviewing the meaning. So we also said we could look at some graphical representations for our functions. And so here we have a graph, and we see our graph for measuring the time in seconds and the height for the flight of a projectile. So based on that, we want to be able to answer the following questions. All right, and as you're looking at your notes, we want to see if we can find the y-intercept and explain its meaning, the x-intercept and explain its meaning. Do we have any intervals where the graph is decreasing, increasing, or where it's constant? So let's give you a moment to go back to your graph, and let's mark it like we were doing before. So take different colors and mark your x-intercepts in one color, y-intercepts in another. Put your pluses for where it's increasing, minuses where it's decreasing, and see if it helps you answer your questions below, and we'll check. So as we compare our graphs, we talked about using different colors to mark x-intercepts and y-intercepts. So x-intercepts where it crosses the x-axis is here, and I marked that in red. Y-intercept where it crosses the y-axis, that's here, I marked that in green. We could see that we're increasing here to when we get to this point, and then it turns and starts decreasing. And I have the word continuous here because notice, think of the path of the projectile, right? When you launch it, okay, it's going to have continuous. For every second that goes by, it has a specific height that it achieves until it hits the ground. So let's get more specific. We said find the y-intercept. So that is here, and it's a grid point, and that is at 0, 50. So what is the meaning? At 0 seconds, it's 50 feet above the ground. So the projectile began 50 feet above the ground, right? It was launched 50 feet above the ground. The x-intercept we can see here. Okay, and we're going to have to estimate its value because it's not at a grid point. And so we have to think about, well, what does that mean based on the situation? Well, this is a projectile, right? So we could say at about 6.8 seconds, the projectile hit the ground. So we could have our coordinate for that y-intercept and its meaning. Okay. It says we want to list an interval where the graph is decreasing. So let's go back to our graph. And we said we are turning here. So it's kind of starting from this point here until it hits the ground. And that looks like it's about 3, right? So from 3 seconds to about 6.8 seconds, it's hitting the ground. Now at 3 seconds, what's happening? It's changing from increasing to decreasing. So because it's changing, we need a parenthesis to represent that. And since it hits the ground, it's ending, we can have a bracket to represent that. So for the decreasing interval, we would say parenthesis 3, comma 6.8. Also, we also can write the interval as an inequality, as x is greater than 3, but less than or equal to 6.8. So that's where it was decreasing. We also want to know, well, where was it increasing? So if we go back to our graph, we know it was launched and it increases, right, until it turns to decreasing. Well, it started increasing from 0, a definite beginning, and then it changed at 3. So we could have definite beginning, that's a bracket. And then because of the change, we need a parenthesis. So if we're using the interval notation there, we have our bracket 0, comma 3. Again, if we're going to write it as an inequality, we'd say x is greater than or equal to 0, but less than 3. Our last part said list an interval where the graph is constant, neither increasing or decreasing. Well, if we look at our graph, the projectile either increased its height or decreased its height. It wasn't constant, so we have no interval where it's constant, staying the same. It's either increasing or decreasing. So we'd say none, or NA for not applicable for part E. So that's a quick review of what we've been doing in the past. Now this point where it was changing over this continuous function from increasing to decreasing, and notice that's the highest point on our graph, we could refer to that as the local maximum for our graph, right? So our local maximum occurred at 3 seconds, and we could then work on seeing, well, when we know when it occurs and at what height it achieves, and we'll work on that later. But we could label this as a local maximum, the turning point on our graph over the continuous, right, path of the projectile. So we've been talking about the intervals of our graphs, increasing, decreasing, constant, and we've been talking about inputs and outputs. And we want to go back to the idea about domain and range, where domain is a set of all the possible input values, those x values being used, and the range is a set of all the possible output values, the y values being used. And so we have a couple of situations here where we want to actually write the domain and the range. So as we look at these two situations, well, one, we could review, are they functions or not? And remember, a function, every input has one output. So if I look, every input here has one output, so it's a function. Every input here has one output, so that's a function as well. So if we want to talk about the domain, we want to look and list out the inputs and outputs. So for this, right, here's our graph. Now if we want to talk about the domain, well, what input values are we using for the graph? So if our scale is 1 here, we have an input at 1, 2, 3, 4, 5. Those very specific inputs are being used for the graph. So we're going to make a list, and since they're all solid points, we're going to use brackets to say, hey, we're using all these exclusive points. Inputs of 1, 2, 3, 4, 5. Now the range are the outputs. So what are the outputs that go with those inputs? Well, this is an output of 1. This is an output of 3. This is an output of 5, 7, and 9. And so we're going to list those very specific outputs that are being used for our range. And since they're all filled in, they're being used, we have brackets. So can you list the domain and range for the second scenario? So again, our domain, the set of inputs that are being used. So let's see, scale of 1, so we have inputs at 3, 4, 6, 8, and 9. And our range, outputs of 1, 3, 4, 6, and 9. Now we want to notice that this is a little bit different than the graph that we had in our previous examples. These are very specific points that are being used, right? It's not one continuous flow from what we had previous, right? Where we had all the values, all the times represented from launch to landing. These are very specific times. So we don't call this continuous data. This would be called discrete data. And with discrete data, you have to list out all the individual data points that are being used for the inputs and outputs, or domain and range, because there are no in-between values being used, right? They're not connected by a curve or a line. We're just using these particular places. So anytime that happens when you have graphs that look like this, discrete graphs, you're going to have a list for your domain and range. If it's continuous, like we had for our previous example, when we make our domain and range, we can actually use the interval notation to show that it's continuous for that. So let's take a look at a couple other examples. So here we have our graph, and we can see that it's a line segment, PQ. There's a couple of things we want to talk about it. So we're reviewing a lot of concepts in today's lesson. One, is it a function? Would you classify it as continuous or discrete? What would be the domain? What would be the range? Do we have any increasing intervals, decreasing intervals, any constant intervals, any x-intercepts or y-intercepts? As we have done in the past, I would highly suggest that you use different colored pens to mark your x-intercepts and y-intercepts. Use pluses, minuses, and zeros to mark increasing, decreasing, and constant intervals. And then if you have those marked, it's very easy to go back and talk about listing out the intervals for those and the domain and range that goes with them. So let's take a look at this one together. So we're talking about looking at the graph and marking it up. We know that it's decreasing, so I put a minus. Also, do we have any x-intercepts or y-intercepts? Let me change my pen color. Is it crossing the x-axis anywhere? Yes, about here. So there's an x-intercept. Crossing the y-axis anywhere? Yep, there's a y-intercept, so we know we have those. And let's see how that helps us answer our questions. First one was, is it a function? Does every input have one specific output? So as I look, it's a one-to-one relationship, or some of you are kind of thinking about that vertical line test. It's only touching our graph once, so yes, we've got a function. Is it continuous or discrete? Well, all the in-between values are being used, right? We can see that it's continuous, it's connected, so we would say that it's a continuous function. Then it's asking about domain and range. So domain is a set of inputs that are being used. So where do the inputs begin? The inputs begin here with P, right? -3, it's being used, all the way to Q, to 4. And because it's continuous, we could use the interval notation to take care of that. So look, definite beginning, definite end. That means we need brackets. And we're going from -3 to 4. So we can go bracket, -3, comma 4. If you wanted to write it as an inequality, you could say x is greater than or equal to -3, but less than or equal to 4. Usually, students like to use interval notation because they think it's more condensed, they're more comfortable with it, but either one would be acceptable. We're probably going to go back and forth between the two, but as you go on in mathematics, you'll most likely use interval notation more so than inequality notation. The range, the outputs. So let's think. It's always lowest to highest. So the lowest output is here, right? -1. The highest output is here at 2, and it's continuous. We're using all of those in between values. We could have bracket, -1, comma 2, bracket. Again, if you want to do inequality notation, x is greater than or equal to -1, but less than or equal to 2. We don't have any increasing intervals, so we would say none. We do have a decreasing interval. In fact, the only thing that's happening to our function is decreasing. So that's from -3 to 4. Very similar to our domain. No constant interval, so we can say none. Now going back to what we first saw with the x-intercepts and y-intercepts, because they're not happening at exact grid points, we're going to have to estimate. So we're going to have to say about and then list the coordinates. The first one was the x-intercept right here, right? So it looks like it's a little bit more than halfway, so we could say about maybe 1.6, comma 0. And our y-intercept is here. So again, we're going to estimate again, not quite at 1, so maybe about 0.8, so 0, comma 0.8 for our y-intercept. At this point, we just have to estimate, so that's why we have the about in front. If we had a rule for this function like we have in the past, we could do some substitutions and some solving, but we don't have that, so we're going to have to do some approximations. All right, let's try this next example again. Based on your givens, I would mark up your picture with your colors, your pluses and minuses and zeros, and let's see what we can do. So here I marked my graph with my key features in terms of the intervals, how they're increasing, decreasing, constant, and any x and y intercepts that we have. So to answer our questions, this is a function because every input has one output. It is continuous because we're using all the in-between values from the beginning to end of our function. Our domain, right, our function begins with the input of -3, ends at 3. So I'm going to do interval notation, bracket -3, comma 3 bracket. If you did inequality, x is greater than or equal to -3, but less than or equal to 3. The range, right, the lowest y value, output value is at -3. The highest is at 1. So I could do bracket -3, comma 1 bracket. Again, if you're doing inequality notation, x is greater than or equal to y is greater than or equal to -3, but less than or equal to 1. We have increasing intervals. We have 2 of them, here and here. So definite beginning, so I need a bracket, -3, comma, -1 parenthesis, because it's changing what's happening at the interval. I also have one happening at 0 and 2. So I'd say parenthesis 0, comma 2, parenthesis, because again it's changing. So we have 2 intervals that are increasing. We have one interval that's decreasing, which is from 2 to 3. So I'd have a parenthesis 2, comma 3 bracket, because it's ending. And constant intervals, yep, -1 to 0. And again, they're changing directions at each part of the interval, so I need parentheses for those. X-intercepts are happening at grid points 1, 0, and 3, 0. Y-intercept, again, happening at grid point at 0, -1. All right, here's another scenario that we want to identify our key features. Mark up your picture like before, and then we will check your results. So here I have an increasing interval, so I have a plus. If I'm looking for key features, I do have one x-intercept here and one y-intercept here. It is a function because every input has an output. It is also continuous because we're using in-between values. The domain goes from -6 to 5. -6 is included, so -7 to 5. -7 is included, so I have a bracket. 5 is excluded, it's open, so I have a parenthesis. My range, my lowest value here, -3, and it's included, so bracket. Highest value, 1, but it's open, not included, I need a parenthesis. Increasing interval, well, the entire function is increasing from beginning to end, so my increasing interval will look similar to what I have for my domain. I do not have any decreasing intervals or constants, so we would say none or not applicable. My x-intercept happens at a grid point, 2, 0, so I have my coordinates. My y-intercept, I'm going to have to estimate, it's very close to 1, so I said about -1, I should say, about 0, comma 0.9, or maybe you said negative 0.8. We're just estimating that y-intercept. All right, let's have you look at this scenario and answer the questions, and we'll check. So this is a decreasing relationship. It is a function. Every input has one output. We have one x-intercept here and one y-intercept there. We have a continuous function. The domain is going from -2 inclusive to 3 exclusive because we have our open point. The range, again, lowest to highest. So again, exclusive at -5, right, open, to 2 included because it's closed. We have a bracket. No increasing intervals. The decreasing interval should match our domain because it's the same. No constants. X-intercept and y-intercept we are going to have to estimate. So we said the x-intercept happens just past 0, so I said about -0.20. And our y-intercept, again, just past, that kind of looks like it's halfway, so I said about 0, -0.5. All right, here's our next scenario. See if you can answer the questions, and then we'll check. Here we have an increasing continuous function. Our domain begins at 1 and goes to positive infinity, so we have a bracket 1, comma, positive infinity, parenthesis. Range, our lowest output, bracket 2, comma, positive infinity, because it doesn't stop increasing. Increasing interval should match our domain. No decreasing, no constants. X-intercepts, we don't have a place crossing the x-axis. Same thing for the y-intercept, so they do not apply for these, so not applicable. Here's our last scenario. Mark up your graph to answer your questions. Be careful with your notation. All right, so we can see we have one y-intercept, two x-intercepts, one increasing interval, one decreasing interval, and we have a change in direction here at this point. So it's a continuous function. We have our domain going from -infinity to positive infinity. How do we know that? Again, we have the arrows. That means this is going to keep going like this and this. So they're going to still have inputs to the right and left being used. Our range, our lowest output. Now, remember, these are going to continue on. So this is going to continue decreasing, decreasing. So we have no lowest values. We're going to go from -infinity to our highest 2, and we're stopping there, so we have a bracket. Increasing intervals. We're increasing from -infinity to the turning point that happens at 4. So we need a parenthesis around the 4 for the turning point and a parenthesis around -infinity. Decreasing interval, again, it's changing directions at 4, but it will keep decreasing to positive infinity, so we have parentheses around both of those. No constants. X-intercepts, those are happening at grid points at 2, 0, and 6, 0. And y-intercepts, that's also happening at a grid point, 0, -6. Now this turning point here on our graph, right, where it's changing from increasing to decreasing, since that is the highest point on our graph, we could say that is a maximum that happens at 4, 2. And we'll work with more of those as we go forward. So today you're going to continue practicing, talking about the key features, domain, range, x-intercepts, y-intercepts, increasing, decreasing, and constant intervals, practicing your interval notation for those. And we're going to check your progress in the next lesson.